Welcome to Variables and Mathematical Operators lecture. So, variables. Variables are assigned objects, and these objects can be numbers, strings, lists, data frames, and so on. If you think of a variable as an empty box that's filled with an object, as a similar process to assigning a variable. Then we have mathematical operators, which include, of course, addition, subtraction, multiplication, power, division, floor division, modulus, int, which is short for integer, and float. Don't worry about the last four of these mathematical operators. They're quite simple concepts to learn, which we'll be covering in this lecture. So we'll just scroll down a little bit to make some space, and we'll do some simple mathematical operations. So 100 plus 20 gives 120, subtraction gives 80, multiplication gives 2000, and then lastly division gives 5.0. Okay, and let's say we do power, so let's just make another space here, and if you hold control and then do left tab, we can print out the output twice. So we've got print, and we do 4 times 2. In this case I'm going to change the top one here to 4 times 4, and then we run this and we have the output of 16 and 16. And if we do 3, we're going to get 64. So essentially it's 4 times 4 times 4. And we can just show this here as well. On the top line, we have 64 as well. So that's the power operator. And then let's say we do var equals 5. And I'm going to make some space here again as well. So we just tap on the empty space here, then press L. Oops. So just tap here, that goes blue, then press L. So we want all of these lines here, 2 to 5, with prints. So again, if you hold the control, then left tab, and left tab, and then we type prints, and we'll do, let's say, 40 divided by var. And we're actually going to change the last 3 here. So var is just normal. This line here, 2, is just going to be simple division. This one here will be floor division. And then instead of division, it's going to be modulus with the percent sign. And then lastly, we'll show you the actual process of the calculation by var. So 40 minus, if I recall, it's going to be 8, because 5 fits into 48 times var. And then we do shift and enter to run it. And as you can see, we have the output of a float, an integer, and 2 zeros. So we have actually 3 integers and 1 float. And you can tell it's a float because it has a decimal number. So what's happening here? Well, the division is quite straightforward, but the floor division is simply removing the decimal number to give you only an integer. And then with the modulus, it's answering a question, and that is, how many times does 5 fit into 40? If it fits in equally into 40, then you have 0. But if it doesn't fit equally into 40, then you have 1. And that's what's happening here. So, of course, 8 times 5, and then you have 40 minus that is going to give 0. So let's say we do something a little bit more intuitive. So let's say we do 3, and I run this. And as you can see, 3 fits into 40 13 times, but leaves a remainder. So if I just change this to 13, we should get the same output as the modulus, 1. Okay. Let's say we do something a little bit more intuitive. So instead of 13, we'll just put that to 3. And we do control and left tab, and left tab to delete the 40s. And we'll do 9. And as you can probably imagine, it's quite straightforward here. So 3 fits into 9 exactly 3 times, and therefore you have 0. If we were to do 2 and run this, we get 4.5. So 2 fits into 9 4.5 times with division, or rather, sorry, 2 fits into 9 4 times. We have floor division here with 4, and you have a remainder of 1. So we just change this to 4. You have the same output for the modulus. And let's say we were to do 4, just change that to 2. And as you can see, of course, 4 fits only into 9 2 times or 2.25 times, and therefore you have a remainder of 1. Okay. So moving on from that, let's say we do x, y, and z is equal to, say, 25, 80, and let's say 9.12345. And we run them. We have 25. Just going to scroll down a little bit actually. And then we do y, you have 80, and then z, you have 9.12345. Okay, so if we were to do type x, we get int, and the same applies with y, int, and with z we get a float, and that's because it has decimal numbers here. And let's say, for instance, you wanted to convert one of them into a float or an integer. So if we want to convert x into a float, we do, let's say, x underscore float equals float x, and then if we do type x float and run that, we get a float. So we just remove the type, and you have 25.0 instead of 25. And likewise, we can do the same with z. So we do z int equals int z, and we do z int, and you have 9 instead of 9.12345. And we can just check that with type z int, and you get int instead. Great. So that concludes my lecture on mathematical operators and variables. If you have any questions, feel free to ask in the Q&A forum. Thanks. Welcome to the Boolean and comparison operators lecture. So here we have Boolean operators, which can be either true or false. The numerical substitute is 1 for true, and the numerical substitute for false is 0. Then we have the comparison operators, whereby is equal to has two equal signs, is not equal to has the exclamation mark with an equal sign, then greater than has the arrow pointing to the right, less than has the arrow pointing to the left, then it greater than or equal to has the arrow pointing to the right with the equal sign, and then lastly, less than or equal to has the arrow pointing to the left with the equal sign. And here we have the examples, so true. So all of these statements here evaluate to true, and for the false, all of these statements here evaluate to false. So going from top to bottom, 2 equal to 2 is of course true, and likewise 3 not equal to 10, 10 greater than 5, 9 less than 12, 12 greater than or equal to 10, 7 less than or equal to 7. And just for these last two here, 12, even though it's not equal to 10, it is greater, and therefore it is true. Likewise, 7, even though it's not less than 7, it is equal to 7, and therefore it's true. And all of the above comparison operators can be used to create something called chain comparison operators. And here is an example where you have 10, which is greater than 5, which is true, but 5 is not less than 2, and therefore the entire statement evaluates to false. Scrolling down now, we have logical operators. So we have and, or, as well as not. And if you use not, you can create what's called inverse booleans. So the not keyword can be used to create an inverse boolean output. So if I just delete this, and let's say we just make another space here, you hold the control and then left tab on your mouse, print, and we'll do true, and we'll delete this one here, make it false, and then we output, so we have true and false. And if we were to do the inverse, we simply hold the control, left key on the mouse, and do not, and then run this, and you have the opposite now, so false and true. Okay, so let's just scroll down a little bit, let's make some space here, and let's make a few lines. So if you click on here, then L, you get 1 to 4, and if we do like before, so just hold the control and left tab, so we've got print, and we'll do true, and here we'll do equal equal true, not equal to true, which should be lowercase there, and then equal equal to false, and not equal to false. We'll actually do two more. So print false equal equal to false, and print false not equal to false. And then we output this. Okay, so the outputs are true, false, false, true, true, and false. So what's happening here is that true, of course, is equal to true. True not equal to true is false. True equal to false is, of course, false. True not equal to false is true. Then we have false equal to itself, which is, of course, true. And false not equal to false is false. Okay. And now let's just make a few more lines like before. Click here in the white space, L, then hold Control, left click, and left click. We'll do print true, or in this case, we'll do false for this one, and false, and then and false or true, and we'll change this to false, true, and false. And we'll run this, so we have true, false, true, false. So what's happening here with Python is that it's running through this cell for these 4 lines of code, and it's trying to find if there's a true. If there's a true statement, it will output true. Else, it will output false. So here we have true or false, so it outputs true. If you have true and false, then you only get false. Therefore, if you do the third line, true and false, or true, this here evaluates to false. So it's equivalent, the third line is equivalent to that of the first line. That's why you get true here on the third line of the outputs as you do on the first line of the output. And then lastly, the line 4, false or true and false. Well, this evaluates to false, so essentially it's another way of saying false or false, hence you get the output of false. Okay, just going to scroll down a little bit. And lastly, we'll do print true equal equal to 1 and false equal equal to 0, and we'll do a sep. So sep equal to, let's say, semicolon. Run that, and we have true and true, because true, the numerical equivalent is 1 and the numerical equivalent of false is 0. If we were to change this to say, let's say 100, and let's say, I don't know, minus 90, we get false and false. Okay, so now let's do 10 equal to 10. In fact, actually, let's just do some prints as well. So we'll make some lines here, L, and just do some prints so we get all the values out at the same time. So here we're going to change the second line to 3 and keep this as 3, but I'm going to change this to a not with the exclamation mark, and then not here as well. So as you can see, true, false, true, false. So 10 obviously is equal to 10, so therefore you have true. 10 being equal to 3 is false, 10 not being equal to 3 is true, and 10 not equal to itself is obviously false. Okay, and now we're just going to do some greater than or less than with the arrows. So 100 less than 3 is obviously false, and if you do, let's say 10 greater than, let's say 1 is true, and then we could do, let's say 100 less than or equal, so it has to be together, less than or equal to, let's say 200, which is true. And likewise, if we were to get rid of the equal sign, it's also true. If we were to do greater than, it's false. greater than or equal to is also false. If on the other hand we want to do, let's say 90, it's true. And if we were to change this, we get false. Okay, so let's do some chain comparison operators now. So let's say we do 50 less than 100 and 10 greater than 2. We get true because 50 is less than 100 and 10 is greater than 2. And we could also do, just scroll down to make some space here, we do the opposite. We're going to get false. So even though this is true here, this here is false. 10 is not less than 2. And let's say we do 400 less than or equal to 500, and 3 is not equal to 3. And we get false because even though 400 is less than 500, 3 not being equal to 3 is false. We're to change this to an equal sign again, so two equal signs, we get true. Okay, and let's say we do 4 less than 5, and 5 is greater than 1. We're going to get true. So this chain comparison operator, this is the real first chain comparison operator, I suppose you could say, but we're using two chain comparison operators here potentially if we like, so we'd have to put another arrow here. So say for instance we do 50 greater than 3 and greater than 1. We're going to get true as well. And what we can do is and if we change this to or, we'll get true as well. Let's say we change this to 100, we'll get true. But if we change this to an and, we're going to get a false, because both of these chain comparison operators have to be true in order for there to be a true output, otherwise it's going to be false. And lastly we'll just do 10 greater than 2 and 4 less than 2, or 100 greater than 40 and 55 not equal to 40, and we get true. So it's even though, for instance, 10 is greater than 2 and 4 is obviously not less than 2, so this side is going to be false. However, this side here is true because 100 is greater than 40 and 55 is not equal to 40. If we were to, for instance, change this, then we get a false. Okay, great. So that concludes my lecture on comparison operators with Booleans. I hope that's been enlightening, and if you have any questions, feel free to ask in the Q&A forum. Welcome to Index, Slicing, and Stride lecture. So the elements of the string can be indexed. Slicing strings depends on indexing. And then we have stride. So let's say we have a variable called letters, which contains a string of A, B, C, D, E, F. And then we do the first index. So let's say we have an index of 0. We're going to get the output of the string A. And if we were to do, say, 5, we'll get the output of F, because we go 0, 1, 2, 3, 4, 5. And there are a total of 6 elements within this string. If we were to also do -1, we'll get F as well. Okay, so let's say we wanted to do slicing. Well, this also includes another index. So note that we have first index and last index separated by a colon. And let's say we do 2:4, then we get the output of the string CD. So what's happening here is that C is the second index. So 0, 1, 2, 2 for C, and then we go 2, 3, 4. But note that we don't include the fourth index. So we don't include E, we only have C and D. Okay, and if I were to do, say, for instance, 2:5, what we're going to get is C, D, and E, but not F. So it's always one less than the actual number. So you can think of this as 4 minus 1, which will give 3. Okay, and what if we want to do stride? Well, similarly, we have a colon here that separates the index, the last index, from the interval stride. So if we were to do 1 colon colon 2, we get BDF. So what's happening here is that we have 1 as the index that we're starting with, and then we're counting by 2 each time. So stride is the interval or step size that we're going by. So 0, 1, 2, so we'll have D, and then 0, 1, 2, and then we have F. Hence we get B, D, and F. So let's take a look at another example of a string, and this time it's going to be a variable called talk. So we're going to be indexing. So talk equals hello heaven, and note the space in between the O and the H, which is also counted. So if we were to do len talk, we'll get a total of 12 elements within this string. So let's say, for instance, we start with talk 0, we're going to get H, and if we do talk 5, we get the actual empty space in between the O and the H. If we were to do talk 9, we'll get the string of V, which you can see here, 9 for V. If we were to do 11, we get N, which you can see here, 11, N. And if we were to also do minus 1, we get N, which is the same as I said before with the variable called letters, where we did minus 1 and it gave the output of F. Okay, so let's say we take a look at slicing now. And of course we separate the first index and the last index by a colon. So if I were to do talk 4 colon, we'll get oh heaven. So what's happening is that we are starting at 4, which is going to be O, and then we're counting the rest of the elements. We're including all the other elements within the string. And if we were to do 3 colon 5, we get low. So we're starting at 3 for L, and then we go to O, 4, but we're not including the empty space here, which is the 5th index. And if I were to do talk 6, I get H, and I can actually add them together. So I can have an index, and I can have a slice and add them together. So if I do 8 colon, I'm going to get A, V, E, N. So that's going to be 8 for A, all the way to 11 is N, and you get the output of haven. And if you were to do talk 3 colon 9, you get low, H-E-A. So we're starting at 3, and we go all the way, but not including 9. Hence we get low, H-E-A. Okay, then moving on to stride. The interesting thing about stride is that when we're indexing, we're counting by positive numbers from 0 to 11. But when we're doing stride and we're counting negatively, we start at minus 1 and we go all the way up to minus 12. So if we're to do minus 12, we get H, but if I do 0, I get H. Okay. And if I were to do 11 here, I'd get N. And if I were to do minus 1, I'd also get N. And let's say, for instance, I do slicing. So we have talk 2 colon colon 6. So this is actually a stride. Excuse me, not a slice. So this one is a stride. Number 6 here is a stride. So you have LA as the output. And what's happening is that we start at L, and then we're counting. So 0, 1, 2, 3, 4, 5, 6. Hence you have LA. And if we're to do a slice of talk 6 colon talk 2 colon 6, excuse me, we have LLO. So we're starting at the index of 2, and then we're going up to these, going up to 6, but not including 6. Hence we have L, L, O, and the empty space here, as you can see. Okay. And then if we do some more strides, so let's say we do 11 colon colon minus 1, what's happening is it with the backwards. So instead of it being hello heaven, it is the opposite way around. So we're starting at 11, and then we're counting negatively each time. And if we're to do another stride of 1 colon colon 2, what's happening here is that we are starting at E, and then we're counting every second element. So E, L, empty space, E again, V, and then N. Okay. And then we can do negative strides. So let's just say, for instance, we just do talk 1 colon colon 2. So we've already seen that one. And if we were to do talk 0 1 1 talk 0 colon colon 2, we get every second element starting from 0. So this is similar to the first one here. So what's happening is that we start at H, and then we go L, O, H, A, E. Okay. And if we were to do another stride of 0 colon colon 7, we get H, E. So we're starting, of course, at the very first element, which is the index of 0 for H, and then we're counting by 0, 1, 2, 3, 4, 5, 6, 7, hence we get E. And if we were to do just a slice as opposed to a stride, note that it only has 1 colon. So this is a slice on the right hand side, but here on the left hand side is a stride. And with the slice we get hello H. So we're starting at 0 and we're going up to H, and not including the 7th index, which is E. And lastly, if we were to do a stride of 4 colon 10 colon 2, we get OHA. So we're starting at O, and then we are going all the way up to E, the 10th index, and we're counting by 2. So 0, 1, 2, and then if we go to the second one, that's going to be A, but we're not including, of course, when we do slice here, this is actually a stride altogether, but if we just include 4 colon 10 and ignore the colon 2, it doesn't include the last elements, which would be E, hence we get OHA. And then lastly, we have talk colon colon 10, so we're starting at 4, which gives O, and then we're counting up to a step size of 10, but of course that goes outside of this string, and therefore we only get the output of O. Okay, so I'm going to hop onto the Jupyter Notebook and show a few more examples. Welcome back. So we have a variable here called password, which is a mixture of letters and numbers. And what you want to do, say, is password, where you only want to get the numbers from 1 to 6. So we'll do 0, and we do colon 12, it just grabs everything. And we're doing 12 because if we do len password, we have a total of 12 elements within our string. So what we can do is colon 2, and this is going to grab every second element from the string, starting at the first index of 0, and we get the numbers only, 1 to 6. But what if we wanted the actual password itself, which is going to be Python? Well, what we can do is start at 1, and that will grab us the P, and then count every second element. And then we have Python as the output. Okay, great. And let's say, for instance, we wanted to get only the numbers of 5, 4, and 3 in this particular order. So 5, 4, and 3. What we can do is, just do it on a separate line, or cell rather. say 8:3, this would just grab us nothing, it would be an empty string. But if we do colon -2, we're counting backwards, we get 543. So what's happening here is that we have 8, and we're starting at the 8th index, which is going to be grabbing number 5. So if I were to do password 8, this is going to grab the string of 5. And if I were to do 3, what's happening here, instead of it being what you would expect to be y, it's actually going to be this string of 3. And that's because when you're doing a first index that's higher than the middle index, and then you're doing a slice, a negative stride, sorry, then it's going to be a +1. Hence you get 3 instead of y. And say for instance I were to do 3 colon, let's say 6, you get y 3t. But if I were to do password 6, I get 4 here. So it's not including the 6 elements or the number 6 index. So it's always like a -1. So you think of it like that. A 3 colon 6 -1. And that's why if I do 5 here, you get t. Okay. So let's just show another example there. And let's say we have a string of my underscore course equals this blah 1 is blah 2 super blah 3 cool. And then we're to do len my course, we get 37 elements. That's how many elements there actually are on the string. But what I can also do is dots splits, and this will actually convert this into a string, or excuse me, a list. So we'll have multiple strings within this variable, and now you have only 7. So if I were to do my course, you can see that it's now in a list. So a list contains these square brackets here. So 1, 2, 3, 4, 5, 6, 7 elements within the list, and we can index them as well. So if I were to do 0, we get this. If I were to do -1, we get this is cool. Okay, and let's say we wanted to get only the output of this is super cool. Well, it's quite a similar process to what we had with the password. So we do 0, and we know that we go up to 7 because it's the number of elements within the string, and then we do 2. This is super cool. And I'm going to do my course 1, 7, and then do 2, we get blah blah blah. Okay, so that concludes my lecture on indexing, slicing, and stride. If you have any questions, feel free to ask in the Q&A. Thanks. Welcome to Strings and Len lecture. So strings can be either double quotation marks or in single quotation marks. They can be numbers such as an integer of 200 or a float of 9.1234. And then lastly, you can have a string which is called, in this case, a doc string for multiple lines. And note that it has triple double quotation marks on either end of the string. Now, the letters and numbers in a string are called elements. So for example, the string of the integer 200 has 3 elements, whereas the number of elements within the floats is 6 because you have 9.1234. And then lastly, strings are immutable, and that's something I'll be covering near to the end of the lecture. Then we have len, and this is a built-in Python function. And what it does is simply count the number of elements in a string or list. So say for example we have a variable called greets equal to hello world. If we do len greets, we get the output of 11. Now you might be thinking this would have been 10 because hello is 5 and world is 5 in terms of the number of letters within each of these words. However, len also counts the space in between the words, hence you get the output of 11. So let's say we were to do some variables of cats equals meow in double quotation marks. We'll do semicolon to keep it on the same line. Dog equals in single quotation marks bark and then we're to do print cat, we get the output of meow, and we do print dog, we get bark. But if we're to do cat, dog, cat, we get meow, bark, meow. What we can also do is sep equals versus, and now you have meow versus bark versus meow. And what we can do also is say anything really, say 100, or we could do rainbow, etc. There's another option as well, which is end, and say we could do exclamation marks, and now you have the last meow having the exclamation marks. Okay, so let's say we were to do I'm learning plus, so you can add strings together, Python language plus on Udemy. And there you have it. I'm learning Python language on Udemy. I note that I'm making these spaces here, so if I were to do this, I'm going to get language on as one whole word, which doesn't make any sense, so that's why the spaces are there in the first place. And let's say I were to do the time is plus 10 plus PM. Well, you get an error here. That's because you can't add an integer or a float to a string. So what you have to do is convert this into a string. So you use str, and now you have the output of the time is 10 PM. Okay, so let's say we were to do 200 plus 25. We're not actually going to get the output of 225. What we get is this string here. So it's just simply concatenating them together. If I were to change this to hello, you get 200 and hello. So that doesn't make any sense, of course. And we don't want this. We want an actual arithmetic calculation of an addition. And we were to do, say, multiplication, we get an error as well. So how would we do some arithmetic with strings of numbers? Well, what we can do is, let's say, print would use a val. Now this is a built-in Python function, just like len. So we're to do type eval, you get built-in Python function or method. And if we're to do also len, same exact thing, we get built-in function or method. So let's say I were to do 200 plus 25, and now you have 225 as the actual output. Great. Another way of doing this is eval, let's say we do 800 plus, so it's two separate evals. And let's say I do 90, so you get 890. Okay, great. I'm going to assign that to a variable. Let's call it total, and let's just comment this one out here. Let's say you have cash equals I have got dollars plus total. I'm going to do cash, and it's giving me an error because I'm actually getting an integer. So you want to convert that into a string, and now you have I have got $890. Okay, and let's say I were to do car equals cool car, and then I do len car, you have 8. So as I said before at the beginning, if you were to do a removal of the actual space in between these two words, cool and car, you're going to get 7 now. If I were to make 3 spaces, we should get 10, because it's including the number of spaces in between the L and the C within this string of cool car. Okay, so moving on from that, what we can also do is, say we have Z plus O, and then we can actually multiply, so we do 5 plus N. And then you have zoom, so you could do 10 if you wanted, etc. Then lastly, let's say we have a variable called cosmos, universe, and I were to do cosmos, of course, you get the output of universe. We do type cosmos, you get str for string. And let's say I wanted to change the last letter. So instead of it being universe, I wanted to say universal. So universal. Well, what I could do, and this actually won't work, so if I were to do an index, and you can index strings, so if I were to do 0, I'm going to get U. If I were to do, let's say, 8, I get an error because it's outside of the actual number of elements. So do 7. So what we have here is the final element. So I just change this to a capital E to make it a bit clearer. Okay, so we have the final elements, which is E. And if I were to do, let's say, I wanted to get I, so it's going to be 2. So bear in mind that when we do the indexing, it's always starting at 0. Okay, so let's say I wanted to get rid of E, and I wanted to do this. What do you think is going to happen if I run this? Well, what I get is an error, and this is what's called immutability. So essentially the elements within the string of the universe, or any string for that matter, are immutable. So they are immutable. Immutable. And the same also applies with other types of data structures you've been working with, such as tuples, which are also immutable. But lists are not immutable. They can be mutated. Okay, so that concludes my lecture on strings and len. If you have any questions, feel free to ask in the Q&A. Thanks. Welcome to Formatting Strings lecture. So as a reminder, strings can be in double quotation marks or single quotation marks. You can have multiple words in a line. And this is a docstring for multiple lines, whereby you can see you have triple double quotation marks on either end of the string. And lastly, strings are immutable. Now, formatting is a built-in Python function or method and adds a string to an empty curly bracket. So starting off, we'll just scroll down a little bit to make some space, and we'll create a variable called hi equals hey Arnold. And then we run this, and we get hey Arnold. And if we do .tab, you can see all the list of functions or methods that we can apply to our string. So all the way down to zfill. We go all the way back up. We have the last one as capitalized, and that's the one we'll use. We do, of course, the parentheses. So if I just run it like this, it would say function string.capitalize. So essentially, this here is the string, and we're applying a function to it, and in this case, it's called capitalize. And if you want to run the function, you have to put the parentheses here. And we run this, and we get hey Arnold. So instead of it being lowercase with a H, it's now uppercase. And say, for instance, if we want to do hi.find, so if you want to do autocomplete, just hit the tab button. And let's say we want to look for where y is in terms of the index. So we want to know the number for the index of y. And we run this, and we get 2, which makes sense because if I do hi and then do the index of 2, we get y. And let's try, let's say, we just comment this out by control and slash, and let's say we do O, then you get 7. So if I uncomment this by holding control and slash again, and we do 7, we get O. Okay. And we could do a few other examples. So hi.tab again. Let's say we do count wouldn't really do anything because we already have all of these elements are unique. There's no repeats. But let's say, for instance, we do A. Let's say we do D and D. We run that. We'll get an error because I haven't put anything in at the moment. But if I do A, it has to be in a string, of course. It will say 4 because we have a total of 4 A's. And then we have to do D. We'll get 3 because we have a D here, and a D here as well. Any of the others would just be 1. So if I do E, that's just going to be 1. H is going to be 1 as well, and so on. Okay. And let's say, for instance, we try a few more. So hi dot upper, and this will convert everything into uppercase. So hey Arnold with all those A's there. We can get rid of those actually. And then we run this again. We just get hey Arnold. And let's just assign that. So hi. And now we run this. Of course, we get it in uppercase, but we can also do lowercase. And run that, and it's back to lowercase hey Arnold. Okay, so I'm just going to scroll down a little bit now to make some space. And let's say we do world equals the world is so big, and then with curly brackets, leave that empty, and then we run round. And so what we're going to do is formatting, and all we have to do is dot format and then put a string in, let's say blue. The world is so big and blue. And let's say we create some variables, so A equals blue, and we'll do semicolon to do them all in the same line. B equals green, equals green, and then lastly C equals orange, and then we'll do world dot format and just hit tab for autocomplete, and then we'll do, let's say C, run that. The world is so big and orange. Or we could do A and get blue again, of course, and then we could do B, and we get the world is so big and green. Okay. Now let's say, for instance, we do colors equals in uppercase green, red, and blue. So we've got this space here in between them. And let's say we do color full equals colors dot split function, and then we run color full. There should be splits. Color full, so green, red, and blue. This is what's called a list, but we'll cover that in a future lecture. And so what we're going to do now is say sky. So we're going to create a new string, or rather a sentence of a string. So the sky is full of, then empty, another empty curly brackets, and lastly one more, colors, and then we do sky, run that. The sky is full of something, something, and something colors. Okay, so what we can do is do sky dot format A, B, and C. Run that. The sky is full of blue, green, and orange colors. Now, what we can also do is use the colorful variable that we created. I'm just going to make a few more cells here by holding the shift and enter. And let's say we do sky dot format, and instead we'll do asterisk color full, and if we run this, we get the sky is full of green, red, and blue. So what's happening here is that it's using the list that we created, which is color full, and it's essentially iterating over each of the elements, which in this case are these strings in this list. It's iterating over this list and grabbing each of these elements, green, red, and blue strings, and putting them inside of this string that we created, this variable called sky. Okay, so let's now go on to docstrings, make a few more cells here, and let's create a sentence. So sentence equals, if you hold the shift and then do double quotation mark and then one more time, double quotation mark, so you get triple on either side, and I'm going to write I am very hungry, hungry, this, then empty, so do empty curly brackets, then we'll do super duper, then uppercase duper hungry man. I'm very hungry this something super duper duper hungry man, and we'll write let's eat, do another line, and something again. Okay, and then we run this sentence. So as you can see here, unsurprisingly we have the same output, but we also have these /n lines, which looks a bit strange. And that's because we've made spaces here. So if I remove some, let's say I put super here instead and run this, you're not going to have this /n, but it's, let's say we want to keep it like this. So how do we get rid of these /n's, and how do we add something into all of these empty brackets here? So we have 4 altogether. 1, 2, 3, and 4. Okay, so what we can do is create some variables. So we're going to create, let's do sentence. We'll just create some strings at the moment. Formats. We'll do evening, pizza, chips, and let's say pasta, lots of carbs. We run this. Right, so we still have the /n, so there's a way to remove them. And if we do dot replace, now if you do dot tab, you'll actually get this, which is kind of annoying. So what we do is simply dot replace, and the reason being is because if you do sentence dot replace, you can see it here, but for some reason you actually have to type it out. You can't actually do autocomplete with a tab, which is a bit confusing. So we do dot replace, and just to show you a moment here, if you do the shift and tab, it will give you what's called the docstring, so it tells you what this function does. And if we just scroll down a little bit here, hit the plus icon here, and it will open up. So docstring type, and of course it says a built-in functional method. Okay, so we're going to do replace, and then we do double quotation marks /n, and we're going to replace this. This is what we're replacing. We're replacing this /n with just this. Make a little space in between. If we keep it like that, it's all kind of connected together. So what we do is make a space here, and as you can see now, it says, I am very hungry this evening, super duper duper hungry man. Let's eat pizza, chips, and pasta. Okay. And that pretty much concludes my lecture. I might just do one more example. So let's say we do food equals noodles, veggie, and tofu. And of course, as you probably recall, we can do food dot split, and then we do yum, and now you have what's called a list. So noodles, veggie, and tofu. So we have 3 strings within this list. And let's say I do sentence again dot formats, and instead we'll put tonight, and then if you recall from the colorful example, do asterisk dot yum, asterisk yum, sorry, and then we run this, and of course we have the /n, so we want to get rid of that, so we do replace /n, just one slash, and then a space in between. Run this, and it says, I am very hungry this well, not the best English here, I am very hungry this tonight, super duper duper hungry man, let's eat noodles, and blah blah blah, tofu. Okay, So hopefully that's been enlightening, and if you have any questions, feel free to ask in the Q&A forum.